Hey. Okay, you see the questions here, right? So, just use this then.
That's on the book?
Yeah, that's on the book. So I scanned it, and yeah, so it's like much better. And then, okay, yeah. So basically, I have. Sorry. Yeah, I have this, and then the video. Yeah, the video is gonna recording this. So hopefully, but still, you know, everybody can see the book and just gonna refer to the same book every time.
What is the video gonna record?
I think it's recording on the server, and I'm gonna download it later, then post it on Facebook or something.
Facebook?
I don't know, Facebook, YouTube, yeah. I'm sorry, I just came back from another class.
Trying to promote yourself on Facebook.
Tired, it's been a long day. Long day. Yeah, okay, so let's just pick up what we left off, right? So we have, basically the last part is the model evaluation.
Did you finish that class today?
No, I just talked about bias, but just a quick overview because this can be really quick. And then we could just go through the question from very beginning all the way to the end, if we have time. Okay, so the model evaluation, basically what we're trying to do is that to compare different forecasting, right? So forecasting method, we have naive, SDS, we have moving average, we have what else, like regression, decomposition, classical decomposition, right? All sorts of forecasting method, but then which model is the best, right? Among all those models, then what we have to do is we have to evaluate those models, right? And to evaluate those models, basically we need 6 judges, right? And those 6 judges are following. We have bias, right? We have, who else? MAD, right? We have MAID. Who else? We have MSE, okay? And we have SE. And lastly, we have the R squared. Okay, so these 6 judges basically is going to tell you which model is the best, right, among our other models. So we're going to look at each judges individually, seeing whether or not how to compute each value and what each value tells you, and how they evaluate your model. Okay, so basically in class we talked about bias, right? But before that, before we compute either bias, MAID, or whatnot, the first thing we have to do is we have to compute the errors, right? So the error, first, compute the errors, right? So the errors are intuitively error equals to actual value, right, minus the prediction, right? So for example, if you predicted that the sales is going to be 10, but then the actual value is 12, so the error is going to be equals to 2, right? Because 12 minus 10 equals to 2. And if, for example, if the prediction is 10 and the actual value is 8, so then the error is negative 2, right? So there's the sign and there's a magnitude of it. So if the error is positive, then it means that actual value is bigger than the predicted value, right? What does that mean? Does it mean that it's underestimated or overestimated? If error is positive. Error is positive, then it's going to be underestimated, right? Because actual value is bigger than the prediction. It means that you predicted lower than it should be, right? So error is positive means that you are underestimate. Whereas if your error is negative, it means that your actual value is less than the prediction, right? So it means that you are overestimate. Okay? And that's like the sign, right? The sign of the error, whether or not it's positive or negative. If it's positive means you're underestimate. If you're negative, that means you're overestimate. Okay? So that's for the error. Okay? And the huge or large error, either on the positive side or the negative side, intuitively it shouldn't be good. right? If you make a huge error on your prediction, then it means that your model is probably not going to be good. Okay, so plus minus sign tells you whether or not under estimation, and if there's a huge error either on the positive side or the negative side, it's not going to be good. Okay, so you should have your model that has the smallest error possible. Okay, so yeah.
In the assignment, do we have to do the R squared too?
Yes, so yes, it's already been calculated in the when you do the regression, and then you got 3 tables.
Yeah.
Right. So the R squared is here. It's in the first table. It's already said like R squared equals to something something. Yeah, I can show you later, but yeah, you don't have to like manually computing it. It's already been here. Yeah. Okay, so that was the errors, right? So before you compute the judges, right? So you got the errors term and all the errors. If you make like a 10 prediction, so basically you're gonna have like 10 errors, right? If you make 100 predictions, then basically you're gonna have 100 errors, right? So what to do with the errors? Basically, all the errors has to be computed, using different formula to get all these 6 judges. Okay. So the first judge is the bias, right? So the bias, to compute it, basically you just have to average all the errors. Okay. So you got all the errors term. If you make a 10 predictions, you get 10 errors. To compute the bias, basically just average them all. Okay? So bias, you got to average all the errors. For example, you have 2 models, right? Model number 1 and model number 2. Okay? Model number 1 tells you that the error term, the error or the bias, right? So you get bias from model 1 equals to 5, whereas bias from model 2 equals to 10. Okay? 5 versus 10. First, what does bias equals to 5 tells you intuitively?
It's going to be an underestimate.
On average, right? On average, your model tend to underestimate your results because the error term tend to be mostly positive. So when you average them all, then you tend to have, on average, a positive bias. And positive bias means that your model tend to underestimate the actual values. Okay? Okay, so that's how you interpret the results, right? You got 5 and 10. So, and now compare between the two. Would you prefer model number 1 or model number 2 according to the bias statistic? Model 1 or which model is better, 1 or 2?
Model 1.
Probably model 1, right? Why? Because model 1 has an underestimation issue, right? It's kind of like off by 5 every time. But model number 2, it has a more severe underestimation issue because it tends to underestimate by 10 instead of 5, right? So it means that, okay, model number 1 probably is going to be better because it has bias that is closer to 0, right? So when you basically trying to come up with what would be the criteria for telling which model is better according to the bias statistics. So the closer to 0 is better. Okay, so that's for the bias. Any question? Should be clear, right? So now let's change the numbers, right? So model 1 give you bias equals to, for example, -4, and model number 2 give you a bias of +20. Okay? Model 1, what does it mean, -4?
It's going to be an overestimate.
It tends to overestimate your results, right? Because -4 means that you tend to have a negative error, and having a negative error means that having a prediction higher than your actual value. And that means you tend to overestimate on average, right? And what does +20 tells you for a bias equal +20?
Underestimate.
It tends to underestimate on average, right, by 20. Okay? So according to the bias estimate, -4 versus +20, which model is better according to the bias judge?
Model 1.
Probably about model 1, right? Because it tends to overestimate, but the other guys like tend to underestimate, but it's like a lot, right? So if you don't have a preference between the plus side or the negative side, right? So choosing bias the closest to 0 is probably going to be better.
Even if it's negative?
Even if it's
If
negative,
it
yeah.
was a minus 20, a minus 10 there.
Sure, yeah, let's put minus 10.
Would it be
So,
the same?
okay, yeah. So that was like a kind of rule of thumb kind of a criteria, right? But then, okay, if you see this, what do you think?
I would
There's no like, wrong answer anyways.
I would go for the bias too, because if
Okay.
the underestimated and overestimated 10 units of something.
Sure, yeah. So sometimes it depends on like the business application too, right? Would you rather having an overestimation or would you rather having underestimation, right? Sometimes if you have an overestimation today, so it means if you have overestimation consistently, it means that you tend to produce a lot of things, right? And if you overestimate the demand, for example, then you're gonna have a lot of stuff, left in your inventory, and that's gonna be costly, right? Versus when you have an underestimation, then you kind of like, okay, projecting that the demand is gonna be very low, but then you sell everything out, like everything is sold out. So that's probably a good thing too, right? So that's when you have like a different perspective between over or underestimation. You have a preference between over and underestimation. That's a different issue. But anyhow, for business application purposes, there's no like a hard rule of what to think about which one is better, right? So it depends on the preference. It depends on your business situation at the time. So yeah, there's no rule. But yeah, you got the idea. Okay, but if you were just like a bottom line number, which one is better? Like according to just seeing numbers, then the closer to 0 would be better. That wouldn't be that should be okay. Hey, is that Derica? Oh, so sorry. Yeah, my eyes still. Hi, yay. Okay. Okay. Yeah, I just finished like the review on the bias, right? Okay. So now we can move on to all other statistics, right, of how you compute it. But okay, so far I think we're clear on the bias. Okay, so bias tells you over or underestimation, right? How to compute it, average all the errors, right? The closer to 0 is better. Yeah.
So can there ever be more than 2 models?
Yes,
Okay.
yeah, definitely. Yeah, you can have 10 models, basically all the way to model 10. And then if you use bias, then you say, okay, model 1 gives you bias 1, model 2 gives you 10, model 3 gives you -5. Then you can compare across the 10. Yes, there's a restriction whether or not, how many models you can have. Okay, yeah, but just use 2 because, it's faster. MAD. What does MAD stand for? MAD stands for mean average deviation. Okay, so just by the name, you can tell. You can basically guessing of how not average, absolute. Yeah, absolute. Yeah, mean absolute deviation, right? So by the name, you can basically tell how you would compute MAD, right? So by name mean absolute deviation, basically you would compute it by first get all the errors. Once you get all the errors, sometimes can be positive, sometimes can be negative. You take the absolute value, then everything is going to be positive, and then you average, right? So to compute the MAD, what you have to do is, okay, I'm going to erase this, mean absolute deviation. So to compute MAD, you average absolute errors. Okay? You first compute the errors and then take the absolute value of it, then you average it. Okay? Quick question. Can MAD ever be negative?
No.
Can MAD be 0?
No.
Why? If you have like a very perfect model, right? But that's like gonna be really rare. Like when all the errors are like 0 and then you get the MAD equals 0. But that's like a lower bound. like the lowest value that math can get. So it can be 0, but it can never be negative. Yeah.
Can you repeat the steps of computing the math
Sure.
one more time?
Okay. Let's give a illustrative example. So if you have an actual value, right, and then you have maybe I can draw it over here so that we can use it later. Okay, we have actual value, actual sales, right, and predicted sales. Okay, and there you got errors, and then you get okay, absolute errors. And we can use that example actually, right? So you got sales 76868. Okay, 76868, right? And you probably use, for example, naive method. Okay, so you've got no first predicted sales, and the first value is going to be 7, right? According to the naive, 6, 8, and 6. Okay, and error, the first one, no errors, right? Because you've got no prediction, so no errors. The first one is going to be -1, right? Because errors is equals to actual minus prediction, right? -1 plus 2, 6 minus 8 is -2, 8 minus 6 is plus 2, right? This is the errors. Absolute error, no first value. What would be the first value here? 1, right? Absolute value of -1 is 1. This would be 2. This would be 2 and 2, right? Average absolute errors. So basically just take an average of these numbers.
Oh, okay.
Yeah, so it's 1 plus 2 plus 2 plus 2, that is 7 over 4. So this would be mad. This is mad. Okay? So now, okay, I just ask you that it cannot be negative because you already take an absolute value. That means that it's never going to be negative. It can be 0 when your model is like perfectly fitted, right? But it's possibly it's going to be positive, right? So compare the two models. You have first model being the naive model, right? Model number 1 gives you mad equals to 5, right? Model 2 gives mad 2 equals to 10. Which model is better? Okay, model 1 equals have mad equals to 5. Model 2 gives mad equals to 10. Then which model is better?
5.
5. And why is that?
Same thing about being closer to 0.
Yes, yeah. So basically, mad is going to give you a measure of how how large the error term is, right? So if you have a big error, right, your model have a very big deviation, that means that it's going to give you a very large mad value, right? And versus the other model where the error is going to be relatively small, right? So the mad value is going to be smaller, and the smaller the error is better, right? That's why you want to pick the model with the lower mad value. Okay, so basically judge number 2 tells you that the lower the better, right? Lower mad is going to be better. Okay, now MAPE. So that's, just go very quickly because the rest is going to be very repetitive and it tells you kind of the same story. Okay, so MAPE stands for what? If you read ahead, MAPE. First M is mean, A is absolute, P is percentage, and E is error, right? Basically, just adding the percentage term. Yeah, instead of deviation, just use error, doesn't matter. Okay, so mean, absolute, percentage, error. Okay, so the motivation for using MAPE instead of MAD is that sometimes when you want to measure the errorness of the model, right? When you measure it by dollar value or in different currency or whatnot, or sometimes measuring the dollar value is not going to be accurate. Okay, so when you want to, and it's more intuitive too. to measure the error by percentage error instead of just a pure dollar value. Okay, it's better to compare across different models. So for example, the first model, the error term is the error itself, right? It could be the error term could be like a $1 million, right? That sounds huge, right? It sounds huge, like the error is off by 1 million. But if that 1 million comparing to percentage error, it could be like a 1% off, right? Off by 1% means off by 1 million. So basically, computing the percentage sometimes makes more sense. Okay, and to compute the MAPE, basically just do the same thing almost, except that instead of computing the absolute error, we are going to compute the percentage absolute error, right? Okay, so let's see how you do it. Okay, so the first prediction is 6, actual value is 6, prediction is 7, the error is -1. Percentage absolute error means that we just take absolute value, right, of the error divided by the actual sales, which is 6. Okay, so it's like now your prediction is off by 1/6%, so to speak, right? So that's how you compute the percentage absolute error. You got the absolute error, and then you divide it by the actual sales. You have to get the percentage, so this one is going to be like 16.67%, right? So the first percentage absolute error is 16.67%. It means that your prediction is off by 16.67%. Okay, the next guy is going to be what? +2, okay, divided by 8, right? And then take absolute. Okay, so 1/4 is 25%. So it means that your second prediction is off by 25%. Okay, and then you do the same thing. It's gonna the next guy is gonna be -2/6, right? And that's 1/3. That's 33.33%. Remember that we're doing absolute now, so we just disregard all the negative signs, right? So the third prediction, you're off by 33%. And the last guy, of course, is going to be 2/8, absolute value, and that is 25, okay, percent. Then, mean, right? You already compute absolute percentage error, and then you take the average, right? So basically, it's going to be an average between these 4 numbers, right? And it can be a little bit tricky to compute, but you get the idea. You got a calculator. Okay? And then again, you know how to compute the MAPE, you know why you compute the MAPE, and then we can basically compare the 2 models, right? So for example, model number 1 give MAPE 1 equals to 5%, okay? And then model number 2 give MAPE 2 equals to 10%. Okay, model number 1, you get the MAPE is 5%. Model number 2, you got the MAPE equals to 10%. Which model is better? The first model, right? Because it tends to have lower percentage absolute error than the other one, right? So the lower, the better. Again, lower means better. Okay, also that is lower means better. And bias is a little different. Closer to 0 means better. Okay? Next guy, again, very repetitive and it's almost the same. Okay, number 4, mean squared error, MSE, stands for mean squared error. Okay, just by its name, how would you compute the MSE? Let's look at the name. So the name suggests that what you have to do with the error.
Find the mean average and square it.
Right, yeah. So you have the mean and you have square and then you have the error, right? So by its name, you gotta do it backwards. First you have the error, then you square the error instead of take an absolute or do the percentage, right? You got the error, then you square it, and then you average it. Okay, so how to compute it? It's basically take errors squared, average all error squared. Okay, this should be more intuitive. Yeah, average all error squared. Okay, so that's how you compute the MSE. And for the numbers, right, you got the actual sales, you got the prediction, you compute the errors, and then you compute the squared errors, right? So you got errors squared. Okay, you don't have the first prediction, so no first error. What would be the square error for this term? 1, right? -1 squared is 1. What would be the second number? 4, right? Positive 2 squared is 4. The third number? 4, right? -2 squared is 4. Disregard all the signs because square is gonna have, because it's gonna give you positive number no matter what. Last number, again, it's gonna be 4. Okay? You got squared errors and then you average them. Okay, so it's gonna be 1 plus 4 plus 4 plus 4 is 13 divided by 4, right? And that's like 3.25. Yeah. Question? Yeah.
So for the errors,
Mhm.
for the errors too, you're finding the squares for 2.
Mm-hmm.
So you're doing 2 squared to find 4.
Right, yes. So you know how to get the errors, right? So the errors is basically a difference between actual sales and predicted sales, right? You got the error from actual minus prediction. This is -1. To compute the MSE first, all the errors has to be squared, right? -1 squared is 1, positive 2 squared is 4, -2 squared is 4, positive 2 squared is 4.
Okay.
Right? You got all the error squared. Lastly, it's mean squared error, right? So basically, you got to take a mean or basically average all the errors. So you take an average of 1, 4, 4, and 4. That is 13 divided by 4. That's 3.25.
Okay.
Yeah. Okay. Again, so the advantage of the MSE comparing to the MAPE or the MAD, right? So as you can see that the MAD, right, if you remember, is the average of absolute errors, right? The MAPE is the average of the percentage absolute error, right? So both MAD and MAPE, there's possibility of the downside of using MAD or MAPE because no matter small errors or the large errors, it doesn't really distinguish between small errors or large errors, right? But when you're using MSE, you can see that small errors it's gonna be still small errors, right? But if you make a really large errors, then it's gonna be transformed into a much larger number, okay? If the errors is 10, then you're gonna get square error equals to 100, right? If you make a large mistake, then your large mistake is gonna be inflated by a lot, okay? So why using the error square? Because you really care about the large errors. You don't want your large errors to be ignored, right? If you have a large errors, it means that your model is gonna be very bad. Yes, there's a question? Yeah.
The errors squared is just MSE, so that's just a definite, like,
MSE is the average of all these numbers.
okay.
Yeah. Okay, so basically the reason of using error square because you want to make sure that the large errors are not being ignored, right? And you really care about having a large error. Okay, for example, again, model number 1 got MSE 1 equals to 10 versus model number 2 having MSE equals to 100. Okay? Which model is better, 10 or 100? 10, right? Because the lower the better, again, right? Lower is better. Okay, as you can see, the MAD made MSE, the lower the better. Okay, so model number 1 has MSE equals to 10, whereas model number 2 has MSE equals to 100. So it possibly means that model number 2 have some large error somewhere in their prediction, right? So that's why it really inflates the MSE, and the larger the larger the number, we think that the number is not going to be good. Our model is going to be good. Okay. SE. Okay. To compute the SE, basically what we have to do is to take. I'm gonna erase this part. Number 5. SE stands for standard error. Okay. The name doesn't really suggest how you would, what the formula would be, right? This you have to memorize, but it's going to be very easy because standard error, or SE, basically is going to be equals to a square root of mean squared error. Okay, so to compute the SE, first compute MSE, right, and then take a square root to get SE. It's that easy. Okay, and why do we have to do this? Because MSE has, you already squared the error term, right? So the error term square doesn't really, it's not very intuitive as for the unit, the unit is going to be squared, right? For example, it's going to be like $1 squared, or, person squared or whatnot, and then to bring the unit down to the dollar or the, demand or whatnot, just take the square root. But the bottom line results just going to be the same, right? Where you just choose the lower SE, the lower the better. Still, okay. So for example, if you have SE1 equals to 4 and SE2 equals to 8, right? So you would choose model number 1, right? Because SE1 is lower than SE2. Okay, again, the lower the better. Questions so far?
When you say model 1 and model 2, that means like using regression versus naive method?
Yeah. Yes, exactly. So model 1 could be a forecasting from using naive. Model 2 could be a forecasting from using 4-period moving average, for example. Yeah. Okay, and the last one is R-squared. Okay, so the R-squared is mainly used in regression. Okay, so when you run a regression in Excel, then it's always going to report an R-squared statistics. Okay, and to get an R-squared statistics is to do the following. Right here. Okay, so the formula for R-squared is equals to 1 minus sum of squared errors divided by sum of squared total. Okay? It might not sound intuitive, but okay. Formula for R-squared is 1 minus sum of squared errors and over sum of squared total. Okay? So sum of squared error, so now you can see one is just number, right? 1 is 1. What you have to do to compute the R-squared is you need the two numbers. First is the sum of squared errors. The second term is the sum of squared total. Okay? So the formula for the sum of squared error, it's basically you take the sum of error squared right? It's that easy. Basically, you got the error square, and then you sum them. That would be the sum square error.
It would be 13.
It would, yeah. Just ignore this. That will be 13. Okay. Sum of square total is a little tricky. Okay, it's gonna be a sum of a difference, sum of a difference between actual value minus the mean of actual value, right? And then squared. Okay, the last part is a little tricky, but okay, let's look at this. The first part should be clear, right? Sum of squared error is a sum of error square, right? You got the error square, you sum it, this one is 13, it's clear. Okay, the second part is sum of square total, okay? I'm gonna create another table, another column that compute the sum of actual value minus the mean of actual value, and then you square it. Okay? So, what's the actual value? Actual value is here, right? The number that you're predicting, 7, 6, 8, 6, 8, right? The numbers you're starting with. And then I'm gonna create a column that compute actual value minus the mean of actual value squared. Okay? So let's see what's the mean of the actual value. You got 7 plus 6 plus 8 plus 6 plus 8. And the average value, right? 13 plus 8 is 21, 27, and 35, 35, right? And you have 1, 2, 3, 4, 5. So this is the average of the actual sales. Okay? This column is actual minus mean of actual all over squared. Okay? Actual sales is 7, the mean is 7. So actual minus mean of actual is going to be 7 minus 7, right? And then squared. And then a 0. Okay, that will be the first value.
So,
Yeah.
so the mean of actual is the same thing?
The mean of actual is you compute it from averaging all the actual sales that you got. It just happened to be the same thing as you. Yeah, but the next guy is not going to be the same. Yeah, it just happened to be the same, but it can be a different number. Yeah, just for the first one. The second guy, actual is 6, right? Minus the mean of actual is 7 squared, right? 6 minus 7 is -1. -1 squared is 1. Okay? The third guy, you got 8 minus 7, and then you square, right? And that is 1. This guy, you got 6 minus 7 squared is 1. It's weird. Yeah, because it's not supposed to be like this. 8 minus 7 squared is 1. And then you sum it, you got 4. This one, you got 13. Wait, let me think about it a little bit. Sum actual. Maybe sum square total. Okay. What I'm gonna do is that I want you to just memorize the formula, and I will work on this spreadsheet of what went wrong. But basically, this formula will give you an R square. Okay? And the R square value is gonna be between 0 and 1. Okay? Or 0% and 100%. Okay, so that's what R squared tells. The value is going to be. It's going to be between 0 and 1. For example,
Give us one because
Sure.
it's a naive method.
I'm sorry.
You said it works with regression.
Yeah, it works with
Is
regression.
because-
That could be the
Because
reason.
this is naive.
But it should. I understand. Yeah, but it should be generalized too. I will have to check, but you got the point where, yeah, it's gonna work with the regression method, but I use this to compute with, with the naive method. So that's probably the reason, but I will have to check. But again, okay, so the R square, normally the formula is gonna be, 1 minus sum squared error all over sum squared total, okay? Memorize the formula. And then the number is going to be between 0 and 1, or between 0% and 100%. Yeah.
Will this be on the quiz?
Yes, you can see,
Okay.
you will see on here too. Okay, so now what would R square tells you, right? So for example, the R square is going to be for regression only, right? So for example, if you run a regression of y equals 5 minus 2 and price. Okay, so we've got a regression like this, and then automatically Excel will tell you that R squared equals to, for example, 60.5%. Okay, so 60.5% for the R squared. What it means is that sorry, get it right here. Okay, R squared equals 16.5% means that price, or R squared equals 16.5% means that the variable on the right hand side in this case is price, right? The variable on the right hand side in this particular example is price, can explain sales or demand, can explain variable on the left hand side, and in this case is the demand, right? 60.5%. Okay? So price alone can explain the demand 60.5% of the time, where in like 39.5% you can use other variable to explain the demand. So that's what the R square means, like intuitively.
So we're actually, because that one in the problem, for the assignment, the data analysis already does that for us.
Yeah.
On the quiz and on the test, we're going to calculate ourselves.
Yes, so basically in Excel, it's going to give you, I'm going to show you where to get the R square, right? There's like, you can see there are a bunch of tables, right? You can get the R square from one of those tables, and I'm going to tell you exactly where it is.
And but on the test, that won't be table, right? We have to calculate that?
It's going to be very easy. It's not going to be like this.
Okay.
Yeah, it's going to be like just, it's going to tell you it's going to tell you what is sum squared error, what is sum squared total, and then you just, 1 minus this over this then.
Oh, so we won't calculate both.
Right, yeah.
Got it.
Okay, so again, R squared equals to 60%, for example, then it means that the variable on the right-hand side, which is price, can explain the variable on the left-hand side, which is sales, 60%, right? In the other 40%, another 40% of sales can be explained by maybe using other variables, right? And we talked about it in class. It could be, for example, gender, right? Male versus female. It could be marketing expense, right? Marketing expense can explain the sales also. So basically, the other 40% can be explained by all other variables besides price. So that's what R squared tells you. And also, the more R squared is going to be better, right? Because it means that your model is more convincing, right? Because it knows that, okay, if you get R squared equals like 99%, it means that your model is almost perfect, right? You can explain a lot of variations, a lot of effect that could influence the sales, right? For example. Question? Okay, just to review. Model evaluation. Basically, you try to evaluate which model is better, right? And you have 6 judges, Okay, bias tells you you're gonna have to average the errors at all the errors, and the closer to 0 is gonna be better. Okay, MAD, MAPE, MSE, SE, the lower the better. Okay, so you compute all these statistics across different models, and then see which model has the lower numbers, the lowest number, right? It's gonna be the best model according to all these different criteria. And also the R-square. The R-square is gonna be used for the regression, and the more the better. Okay, because the closer to 100%, it means that your model can explain a lot of variation in whatever variable you try to explain. Yeah.
So for the quiz, would you give us something like the MAD
Yes. Yes.
or the SE? Which one is better?
Yeah. Actually, I'm gonna do it now, so we can look at the So this is like the last piece of lecture I'm gonna do, and then we can just go ahead and do the question.
Is the R square only used for
Regression. Yeah. Yeah.
Okay.
Okay, so now let's do exercise. Maybe we can skip to exercise number 2, because this one we do it a lot already, but it's essentially the same. Okay, let's do 1.2. A 2-period moving average. Okay, you got sales period 1 through 5. You got the sales number 7, 6, 8, 6, 8. Okay, and then can't find a page. So I.
46.
Yeah, it's page 46. Is it 46? Yeah, it's page 46 on this book. Okay. Okay, try fill in the blank, and then we can look at it together. Page 46. Got period 1, 2, 3, 4, 5, 6. Half sales. Okay, let's do it together. Forecast. Right? You don't have the first 2 values because it's a 2-period moving average. Okay? What's the forecast here?
6.5.
6.5, right? And how do you get it? Basically averaging the past 2 values, right? Which is 7 and 6. What's the values here?
7.
7, right? It's the average between 8 and 6. And what's the value here?
7.
7 again, 8 and 6, right? Okay. This is the prediction. And now we try to evaluate the model, right? So therefore, we have to compute, error, absolute error, P error means percentage error, and squared error. Okay? So first compute the error. So you have these 2 numbers, right? What's the first value here?
I'm sorry.
Yeah, sure, yeah.
So how did you get the prediction?
Yes. So the prediction, this model we're looking at is the 2-period moving average, right? So the 2-period moving average, it follows equation YT prediction, right, equals to YT minus 1 plus YT minus 2 divided by 2, right? It's a 2-period moving average. It means that today's value is going to be an average between the past 2 values. Okay? So if you want to make a prediction of the 3rd day, of the 3rd period, then basically the prediction of the third period is going to be an average between the first period and the second period. Okay, so you're just basically averaging 6 and 7, and there you get 6.5. Okay, so that's the prediction. And then for the fourth period, you just basically take an average between the third period and the second period, and so on. That's why it's like a moving average. Okay, so you got a prediction, and therefore to evaluate the model, you got to compute the errors. Okay, so what do you get for the errors? 1.5,
Yeah, 1.5.
right?
-1. And
Negative 1
1.
and 1, right? 1 point, it should be clear. Absolute error, what do you get?
Get 1.5, 1, and 1.
1.5, 1, and 1. Okay? So just basically take an absolute value of the errors. Okay? P error or percentage error, what do you get?
The first one is 18.75.
And how do you get that number?
Divided 1.5 by 8.
Okay, so you basically error, right? Percentage error means that you take an error divided by the actual value, which is sales, right? And then take an absolute value, right? And it's 1.5 divided by 8, and that would be what percent?
18.75.
18.75%. Okay, so that's the first value. The next value is,
16.67.
right, and how do you get it? So it's basically
-1 divided by 6 and take
negative
an
1,
absolute.
right? Error divided by sales, right? And take an absolute value. Okay, you don't care about whether or not it's going to be plus or minus. There you get 16.67%. Okay, and the last value is going to be 1 divided by 8. Sorry, divided by 8, an absolute value, right? And there you get 12.5%. Okay, so that's the percentage error. And the last one is going to be error squared, right, or squared error. You don't get the first two values. And, okay, so, sorry, yeah.
Don't you average all those?
We will, yeah. But I just want to, fill in the blanks
Oh.
first and then we average. Okay, squared error, you got 1.5 squared, right? That's like 2.25, I think. Okay, squared error, -1 squared is 1. 1 squared is 1. Okay, so that's how you fill in the table. And then to compute bias, MAD, MAPE, MSE, and SE, right? For bias, basically you take an average of all the errors, right? MAD, you take an average of all absolute error. MAPE, take an average of all percentage error. MSE, take an average of all squared error. SE, it's basically take a square root of the MSE right here. Okay? So for bias, it's going to be equals to 0.5 over 3, right? That's 1/2. Okay? That's 0.5. Is it right? Yeah.
Yes,
Okay. MAD, what does MAD equals to?
1.17?
1.17?
Yes.
Okay, that's MAD, right? So you basically just take an average of all these three numbers. What is MAPE?
It's 15.97.
Right, so you basically take an average between these three numbers and it's gonna be 15.97%,
97.
okay? MSE,
1.4.
12?
1.42.
Is it 12? It's not 12.
No, it's 1.42.
Sorry, yeah, 1.42, okay? And SE. SE is gonna be equals to square root of MSE, right? And therefore it's square root of 1.42.
1.19? That doesn't sound right.
Yeah. It could be, yeah, it's
Yeah,
possible.
it says 1.19.
19, okay, so that's your SE. Yeah, and that's basically it. That's how you compute all the statistics, right? So for the first prediction using 2-period moving average, these are all what the judges say about your model. Okay, but the number in itself, it doesn't really tells you how to compare with the other models, right? So then you got to compute all these numbers for different models, different models, get a new prediction, you got another, sets of numbers, and there you can compare. Okay, let's look at what kind of question is going to be asking in this case. So the first question asks, what's the forecast for period 6 using 2-period moving average? Right, so it's basically just average between 8 and 6. Right, it's going to be 7.
7, yeah.
Okay, interpret the bias value computed above.
It's
So what's the bias that we computed?
0.5.
0.5, okay?
Under
What does
estimate.
bias equal 0.5 means?
Is it positive? So it's underestimate.
It tends to underestimate, right? Because the average of all the errors is positive. It means that you tend to underestimate your sales. Okay? Because bias is positive, it means that you tend to have positive errors, and having a positive errors, it means that you tend to have an underestimation. So therefore, bias equal 0.5 means that you tend to have a minor underestimation. Okay? The next question, let's see. Okay, interpret the MAD value computed above. Okay, so it says MAD equals 1.17. What does it mean?
An average error, it's like 1.17.
Yeah, you can just say that. So basically, on average, you tend to make an error either plus or minus, right, equals to 1.17, right? So it's 1.17 error on average. Okay? MAPE, what does MAPE say? MAPE equals 15.97. What does it say? What does it mean? Very intuitive too, right? It's like very straightforward. It
Yeah,
says
50%.
basically that you tend to have 16% error from your prediction, right? Okay, and SE. Well, to interpret SE, it's going to be some sort of kind of the same, right? You can see that its kind of value is kind of close to MAD, right? So basically, just tell that with the SE measure, you tend to have 1.19 standard error. It's just that having that error. It doesn't really, tells you in a different story. Okay, so let's go to exercise number 1.3. I'm not going to repeat the exercise, but I just want to give you a heads up of how you would do it, which is basically the same, right? So exercise 1.3. It tells you to do a prediction again, but now instead of using the 2-period moving average, you use the simple exponential smoothing method, right? Where the alpha is given. Okay, you got the 1.4 alpha equals 1.4. First, what you would do to fill this table, you just make a forecast, right? Make a forecast, then compute the error, absolute error, percentage error, and squared error. Okay, and then you get the bias by averaging all these numbers, MAD, MAPE, MSE, and square root of MSE. Okay? And the same thing, you just make a prediction and then you interpret the results. Yes?
Oh, you're gonna let us do that?
For the matter of time, I'm just gonna skip it and look at the next question because I think it's gonna, this is like a very repetitive exercise, but if you have any questions, feel free to ask me after email me. Okay, let's look at number 1.4. Okay, choosing the best technique. Okay, after you did the forecast for naive, moving average, and SES, right? And after you already computed bias, MAD, MAPE, and SE, right? Then you have to answer the question which technique, referring to which technique, naive, moving average, or SDS, has the lowest bias. Are the biases for each of the forecasting techniques in the same direction? What does it mean for the business? Okay, so let's look at what would be the answer in terms of numbers. I'm gonna go to page. You'll just see the numbers. Okay, the solution is on page 143. Okay, so if y'all have the book, have the book too. Okay, let's go to page 143. Do you have the book too? Maybe I can write it down.
I can show to her.
Okay, yeah, that would be better. Okay, so now let's assume that we already got all these numbers, right? And just see the solution here. Okay, so now you can see that, okay, for bias, you got 0.25 for naive, you got 0.5 for moving average, and you got 0.14 for SDS, right? So according to the bias, my question is, according to the bias, judge which model is the best.
The last one. 'Cause
It will
it's the
be
lowest.
SDS, right? Because it's closest to 0, right? So, okay, so that would be how you would evaluate your model, right? So according to the bias measure, SDS is the best, okay? According to the measure, which one is the best? Which one is the best model?
Moving average.
It will be moving average, right? And why? What's the reason?
It's the lowest number.
Is the lowest, right? So 1.17, it means that it tends to have 1.17 error on average, right? And it's the lowest among naive or SDS, okay? And MAPE, which one is the best?
Moving average.
Moving average, again, because it has the lowest average percentage error, okay? And also the SE, which one is the best model according to the SE?
Moving average.
Moving average, again, right? Because it tends to have the lowest standard error, right? Equals to 1.19.
Will we have short answers on the next test?
No, no, it's gonna be multiple choice.
Okay.
Yeah, but some question can be kind of concept checked also. So yeah, but no short answer. Okay, so look at all these numbers, right? Try to answer the first question. Which technique has the lowest bias? So we got SDS, right? SDS got the lowest bias. Are the biases for each of the forecasting technique in the same direction? According to the numbers.
Positive.
They are positive, right? So it's in the same direction. What does it mean for the business in general? If you can
Because they're
explain.
underestimating every time of all the techniques they're using.
Right, yeah, so the technique or your data and all the technique kind of under forecasting every time, right? That would be one reason. And SCS give you the lowest underestimation, right? Tends to be the most accurate method. Okay. Okay, so the next question asks, which technique would you choose to come up with the forecast for this data based on the errors? Briefly explain your choice. Okay, look at the numbers and which technique would you choose to come up with the forecast for this data based on the errors? Briefly explain your choice. Yeah, it's kind of ambiguous, right, the question.
Based on the error or the methods, like the bias, the MAPE, based on those, right?
Yes. It says here the key word is the based on the errors, right? So I would say that if it asks you based on the errors it means that the MAPE, the MAD, MAPE, everything that involve error, not the direction of error, but the size of the error. So that would be it should be a little bit more precise here based on the size of the errors.
Okay.
Should be more precise.
The moving average.
That will be moving average, right? Because moving average has the lowest MAD, lowest MAPE, and lowest SE. Okay, so that's how you would, basically knowing how to compute all these numbers and knowing which one is the best according to each judge, and then you're good to go. This would be like a very easy exercise.
for the quiz, would we have that, the numbers in there already, so we all have to? We have to.
No, you may calculate.
A little bit calculation.
Okay.
Yeah, just very minor. It's gonna be like, take multiple choice.
It
So
won't be like a
straightforward.
long
Hmm?
16 quarters
Nah,
kind of.
no. I'm not gonna be that mean. I'm mean, but not that mean.
It's gonna be like 15 quarters people.
Sorry. No. It's straightforward, really. Oh, I already posted the practice questions. I'm not sure if you saw in Decide to Learn. Yeah, I posted the practice questions, and I haven't posted a solution yet. So basically, you can look at all those practice questions. Some of the quizzes are in there. So yeah, just if you work through 23 questions, you'll be fine on the quiz. Yeah, so look at it and yeah, but there's a solution. But if you have any question regarding how to do the problem, then just ask me. Yeah.
For our final exam,
Mhm.
are the questions related to, like, from the last exam to that, like, to the end? Is it gonna be 50-50, or is it gonna be more of this stuff?
I would say 1/3. 1/3 of the question is going to be from before midterm, and the
Okay.
2/3 is going to be after midterm.
How many questions?
Okay.
50. Final, right?
Yes.
50. Yeah, and 2 hours and a half, 50 questions, so it's like, take your time. Okay, so that's how you would do this question, right? But, make sure that you go back and look at the practice question. Okay, why don't we switch our, direction to page 57, and then we can work on some more recent, stuff that we've discussed in class. So turn to page 57, and then we can do exercise about regression. And I think we did in class too, this example, actually. Oh, it's not here. Okay, forecasting. Okay. All right, I think I did 4.1 and 4.2 in class. Okay, why don't we go to exercise 5 on page 59? Is it 59? Yeah. Let's do exercise on page 59. Basically, it's the same kind of question, and it's going to be very repetitive too. So yeah, we did this in class, and then I gotta do it again. Okay, 5.1. So now what we did was basically the naive, moving average, all the no trend stuff, and the model evaluation, right? So now we're gonna look at the regression stuff. Okay. So first question. Now look at the simple regression table, right? You're computing the predicted y with a single x variable. Okay? Consider the following portion of a regression output to predict home price in $1,000 based on built-up area of the home in square feet. Okay, and you got this table? Okay, I'll give you maybe 1 minute to work on the first two questions. First, write down regression equation to predict the y, or the price of the house. What is the predicted value of the 2,500 square feet home? All right, okay. 5.1, first question. write down the regression equation to predict the y. Okay, so what would be the equation?
Y equals
Y,
minus
okay,
48
equals to
minus 48
minus
times
48 point
767.
48, sorry, 6767, okay?
Plus point
Plus
1215.
Point 1215 x. Okay, don't forget the x. So this would be the prediction function, right? Minus 48, 6767. Okay, right. Okay, there you got the regression equation. Second question, what's the predicted value of a 2,500 square feet home? How would you do this question?
You put the x, you put us to 1,500.
Okay, so basically, x is the house area in unit square feet already, right? So basically, you have to also look at what would be, if there's a differential in the unit, so you have to take care of it. But since the unit is the same, so you basically just plug in 2,500 in the x, right? So you get y equals 2 plus 0.1215, 25 multiplied by 2,500. Okay, and what's the value of it?
So 155.0.
You say 200? 250,
55.
okay?
0.07.
Okay, ish. Okay, so there you get the price, right? The price of the house in $1,000, right? So 2,500 square feet house, the predicted price is going to be $255,000. That makes sense, okay? The third question, interpret the coefficient for area. In other words, what does 0.1215 tell us?
Everything's staying constant for every 0.1215 that your square feet increases, the price is going to increase.
Almost there, but I like how you started. So to interpret any coefficient, right, you start with other things, other variables, right? Other variables being constant, right? To interpret this variable, so basically you can look at the x, right? Increase x by 1 unit, then it's gonna change y by this much, right? So increase your house size, is it house size? House size or area by 1 square foot, right? Then your house price will increase, not decrease, right? Will increase by $215,000, right? Which means that it's going to be $121.5, right? So you have to take care of the unit as well, because y now is the unit in $1,000, right? So 0.1215, it basically means $121.5. Okay? So that's how you interpret the results. Any question? Okay, good. Second question, basically the same. Okay, so you look at the multiple regression. Okay, let's take 1 or 2 minutes looking at the question, and then we can work on it together. Are you going now?
Yeah.
Okay. Yeah. Have a good night. Thanks for coming. can we do it until like 6:10? Would that be still okay? Or 6?
Yes.
Okay, okay.
Well, it's
Yeah, I try to, not to be, rushing, but. Okay, let's do the question together. So just to save time. So you got this big table, right, from the Excel or whatnot, and assume you are predicting the home price again, but now based on 3 different variables, right, as shown is the part in the table. Okay, write down regression equation to predict the y. So what would be the equation? Y equals to negative, right, 41.1668, and then plus, right, point, I have, go to the, look at the coefficient, right? Just ignore all these parts. Just look at the coefficients, okay? So it's gonna be plus 0.0790 multiplied by area, right? So let's call the variable area, and then plus, right, 24.2431. I call it bed, and then plus, right, 17.4852, and I call it brick. Okay, so this would be your regression equation. It's very long, but it's very intuitive too. Okay, now predict the price of 2,000 square feet brick home with 4 bedrooms. Okay, so what would be the price or average price of 2,000 square feet brick home with 4 bedrooms? So how would you do it?
So you put the 2,000 into the area.
Okay, 2,000, right?
And
Okay.
And then 4 for the bed.
4 beds, and for brick, you put what? With the brick home, right? So it says that brick, if yes, 1, if no, 0. Is the brick home, then it's a yes, right? So if it's yes, then you put brick equals to 1. Okay, so you basically just sub in 2004 and 1 into this equation, and then you're good to go. Okay, I'm going to cheat and look at what would be the answer on page 154. Okay, and it tells you it's going to give you y equals to 231.29. Okay, so to the 2,000 square feet house with 4 bedroom and it's a brick house, it gives you $231,290 on average. Okay? The third question asks, interpret the coefficient of area. Okay, so when you see coefficient of area, so you look at area, coefficient 0.0790. So this would be the number that you have to look at. So what does 0.0790 means?
Can we say that the variables are constant or no? Because
Yeah. You can start with given other variables being constant, right? Yeah, always start with this, magical phrase, and there you got to interpret. Other variable being constant, and okay, let's start interpreting. So 0.0790. What does it tell you?
when you increase
Increase.
your
Okay.
house
Size.
of the area by 1 square.
By 1 square foot. Okay, that's good.
Your house will increase by that amount.
Okay, value of the house, right, will
Increase
increase, right, increase by how much? $79, right? So you have to be careful because right now the price is in thousand, right? So it's 0.0790. When you convert it back into $1,000, so it's gonna be $79, right? 1 more extra square foot is gonna give the price increasing by $79, right? $79. Okay, and the last question, interpret the coefficient for brick. Okay, so what does this brick coefficient So again, coefficient for brick, you look at brick, coefficient, this number, right? 17.4852. What does 17.4852 means?
Does that mean the price of the house
Mhm.
will increase by that amount if you have brick on the house?
Exactly, yeah. So if your house is brick, right? Other variable, again, other variable being constant, right? If your house, if you have the brick house, okay, the brick house will have more value than the non-brick house, right? So it's always compare with the other one, right? So the brick house comparing to the non-brick house will have more value, more valuable than the non-brick house, $17,485.2, right? Always look at the unit, and the brick house is more valuable by $17,500. Okay. All right, let's look at any question. Straightforward, right? Should be, because we went over this in class also. Next question, trend line. Okay, so instead of just make a regression with respect to other variables, we can make it a regression with respect to time. Okay, let's take one quick 1 minute to answer the questions, and then we talk about it.
Is this the one we did in class today with reference to accounting
Yes.
to the 13?
Yes. Yeah. Yeah. Kind of like that.
Does it matter that it said, does it matter that it says the data was for 15 time periods and it's asking for 16? Or do we just, oh, it's like on the assignment. Okay.
Okay. Yeah.
I'm tripping.
15. Okay. Okay. Let's look at the question together. Okay. It tells you consider the regression of the price of electronic component used in computer over time. Right. Data on price for 15 time periods was used to run this regression. Okay. So you have intercept, time period, and then always just look at the coefficient. Okay. Not the rest. So basically, what does this regression looks like? Okay. Write down the regression equation to predict the y, or where y being price of electronic component. Okay, so what would regression looks like? Y. Okay.
50.19
Exactly, 15.1905. Okay.
plus negative
Or minus, right? Minus
minus
0.6071, and then x, or time, right? So this would be time or x. Okay, so right, that would be the regression equation. Predict the sales for the next time period, or for period 16. Okay, so how would you do it?
Would I plug in the 16
Just plug in the 16 where?
and the x?
In the x, right? So you got y equals to these numbers minus 2.6071 times 16. right? And then you get, I'm not sure if you calculated it, what would be the number?
I got 8.481.
Okay, 8.48. Okay, so basically at period 16, the price of the electronic component is going to drop to $8.48. Okay, and again, interpret the coefficient for the time period. In other words, what does negative 2.6071 tell us?
Is it depreciation kind of?
Not, no. It's like a industry trend. Like iPhone price tends to go down. This like electronic price tends to go down. It's not like accounting depreciation.
Okay.
But yeah. Okay. How would you interpret minus 2.6071? Other variable being constant. That's good. Okay. Other variables being constant and increase in time period, or it specifically said that one time period is 1 year, right? So 1 more year, in 1 more year, the electronic component price will decrease or increase? Will decrease, right? Because of this minus sign, right? So 1 more time period, the price is gonna drop. Price will drop by $2.6 on average. Yeah, so that's how you would just interpret the result. Again, make sure that the unit is right? It's in years, and 2.6 has a negative sign, so make sure it's decrease, not increase. Okay, the last part is about model evaluation. Okay, I haven't really talked about this in the class, so I'm not sure if I should put it in the quiz. Yeah, but I just want to show how you would do this kind of question. Okay, so this is basically just about the R square. Okay, so to compute the R square, if you remember in Excel, you will be given 3 tables, right? This is the first table, this is the second table, and there's a third table where you look at the coefficient and stuff. Okay, so the first 2 tables will kind of tell you what is the R square and how to get the R square information from. Okay, so if you look at on page 60, summary output, and a ANOVA table. I'm not going to tell you what it means, but yeah. So basically, these 2 tables going to give you information about the R square. Okay. Consider the following portion of regression output for problem above and fill in the highlighted blank. Okay. So the highlighted blank are, the first one is the R square, right? So there's information somewhere here that tells you what the R square is, right? Standard error. There's some information in here that tells you how to compute the standard error. Okay, and there you got SS right here. Okay, so first, what is the formula for the R square again?
1.
Right, 1 minus
Sum of error squared.
Sum of error squared.
Divided by.
Right. Okay, divided by
Sum of total squared.
sum of error total square. Okay. Total error. Or sum of square total. Okay. So basically, to compute the R square, all the information is already in there. Okay. So look at SS. SS stands for sum of square. Okay. Sum of square. And what do we need? We need sum of square error and sum of square total, right? So R square equals 1 minus sum of square error. Sum of square error, it is equals to 54.12 in this case, because sometimes people would call error or residual interchangeably, right? So residual or error, sum of square residual or sum of square error in this case is 54.12. Okay, so in this case, sum of square error equals to 1, okay, minus 54.12. Okay, sum of square error. And the last part that you need is the sum of square total. And the sum of square total is nothing but this number. Okay, because this is sum of square total. And total is 1957.33. Right, and then you can compute the R square.
Is that all you do for this problem?
And the other one would be the standard error. Yeah, there's another one. But okay, what number do you get?
0.276499108.
Okay, but this is only this part, right? You have to subtract
Yeah,
from
subtract
1. Right, yeah. So it's going to be 1 minus 0.027-ish, right? So it's something like 0.973. Okay, so that's how you get your R square, right? Just basically plug in the relevant information that you need to compute the R square. Sum square error, sum square total. Okay, and the last part is the standard error. So, standard error, again, what's the formula for standard error? Or SE, it's the same thing. Standard error,
The square root.
square root of
MSE.
mean square error, right? So, what you need to look at is only where the mean square error is. Okay, and when you look at the table, you see MS, right? So just look at MSE, and where the MSE is MS of the residual, right? Sometimes people call it residual, sometimes people call it error. So basically MS residual or MS error is still the same, is 4.16. Okay, so then standard error is going to be the square root of 4.16. And that's it. It should be, I don't know, 2 point something.
2.4.
2 point, is it 4? Okay,
16.
there you go. Yeah, that's it. And the rest of the question are basically either we already covered in class or it's very repetitive. All the questions are already, being explained. It's not that bad, yeah, but at first glance you kind of see like, oh, there's a lot of information where to look at, but once you know where to look at, it's actually very easy. Yeah. Yeah, so, okay, make sure that you go over the practice questions and look at the solutions in this book. Basically, I already explained how to do it, the logics and everything, and the solutions are already in here, so it should be fine. But if you have any extra questions, just let me know. That's it. Thank you. Sure. Let me put this on. So make sure that everything is recorded.